Here's a little adjustment that has been made to the smoke box and to the lid. We're running about 185 degrees that I can get out of the top here, and mainly it's through these soldered connections. I put some eyelets into this fiberglass and wedged them in, and then soldered the leads through the eyelets so that we now have a very mechanical connection with the heater, and it's not touching anything, it's not shorted out. I also scraped some of the insulation off of the bottom of the ceramic resistor, and I also scraped some of the, and I lowered it down. As you can see, here's where it was before, and I've lowered it maybe another 2 or 3 centimeters, so it's sitting about like this inside the cavity, so it's a lot closer to the angel hair that is soaked in oil. It's running at 15-16 volts, which is about what it's going to get, track time and all that, and I'm getting a range up to 196 now, which is about as hot as it's been. And if I speed up operations, what I like about this is you get a very distinct puff, right? This is what I think is okay. But as soon as you start cranking up the speed, I can't hardly do this with one hand, but I'll try. You can see you do get some chuff variation, but it's not the same. But I would venture to say you're getting plenty of smoke, and this is 29 ohms, 30 ohms, with the insulation scraped off the bottom, and the bottom is aimed at the fiber. Of course, the test will be to, when I disassemble it, to see how burned or browned the angel hair is. But I think this is a fairly respectable plume. Now, the one thing that is interesting, when I take off the nozzle, you actually get a lot more of a plume, so maybe I'm restricting the flow. And look at that. You get a very distinct puff. So I'm wondering if I need to change the nozzle diameter. I mean, there is room in the housing. I can drill out the thing for a larger diameter. You can see I'm getting a stream on one of my 4 cycles, so my cam is not good. My cam is bad. If I slow this down, you can get 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, and one of them seems to run. I don't know which one it is, but at any rate, that seems to be a pretty good. Maybe what I need is a shorter stack. I don't know. You know, I had the longer stack on. I don't really have a longer stack. I just have one like this. Let's set it out. That. Oh, look at that. That's kind of fun. 1, 2, 3, 4, 5. See that? 2, 3, 4, 5. I'm getting a bounce. I can feel it in the motor pulses. There it is. It's that bounce. There, I'm getting a bounce, a pulse, like a dit 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 dit. Even though you're not getting it in the sound. Anyway, the other piece that we want to explore was how hot is the plastic, and is the plastic starting to get soft and all that. And if I can get these out of the way so I can get my hands in there. The plastic is feeling, yes, it's feeling soft. For sure it's soft. For sure it is. I'm pretty sure I can squeeze it in. So the plastic is getting some. Oh, it looks like I've created a leak right there now. Oh yeah, look at that. It's so soft. It's coming up. So yeah, we're melting the housing as we speak. So I'm gonna shut off here. We're melting the housing. Oh, lovely. This is just plastic. Oh, these things are terrible. Okay, now I can probably almost lift that right out. I wonder why that's so hot. It doesn't measure that hot, does it? Oh, wow, yeah, it's up to 218. Something was going on there, wasn't it? Well, I'm going to have to try to see if I can lower the voltage next time, run it at 10. But it's going to be running at 15, and right now I'm running through all of my electronics. I can go into the board and adjust the voltage it's getting, but I'm not sure. But I'll bet you I could poke a hole in this if I got vigorous. Almost. I mean, I can feel it. It's really soft. In areas where it's thin, not back there, but right there. Look at that. I don't know if you can see that. I'm putting dents. I'm putting dents in it right there. Oh, look, I could go through. I could go through. Okay, well, you know, I'm just limited with what I can do with my little printer and the materials that I have to print with. And that's the challenge, and that's where I'm at. I've got to get different material. I've got to get a nylon and a PETG material, which is much more heat, goes up to 300 degrees and maintains rigidity, so it's made for automotive. So I guess there's not a whole lot of reason to continue unless I just want to convert all of these electronics over to this engine and be able to run it, but I still don't have a chuff trigger. This has this chuff trigger here, so I'd have to come up with whatever trigger I want to have on these boys, and I really don't have a good idea yet, other than putting the magnet on the wheel back here, which we do all the time, and it does work well, but you can't run it here. This wheel has to be rotating in order to give you the chuff pulse. One thing after another. Maybe I'll work on my flywheel idea and see if I can get that figured out. All right, well, we'll talk. This is where I'm at today. You did see some smoke, so enjoy that. Bye.